Verilog itself is one of two very popular hardware descriptive languages, two HDLs. The other one is VHDL. I won't be using that. That is probably going to be your most popular language outside of the United States. But if you're in the United States, Verilog is more or less the standard. As far as the actual syntax goes, it's pretty familiar if you're familiar with software programming. It's kind of like a hybrid between C and Visual Basic. Some of the syntax is actual words, some of it still maintains C-like line termination, stuff like that. But there are some hardware-specific things you'll have to get used to. For instance, there are like 3 or 4 kinds of assignment. You can't just assume it's all going to be exactly like you're used to, because there will be some differences. But I can go over what they are, and I will describe them for you in a way that hopefully makes sense. Let's go over a couple of the constructs of the Verilog language so that you're familiar with them in comparison to something like, say, C or Visual Basic. Whenever you have a code block, which is what you use curly brackets for in C, that is no longer the case in Verilog. You're going to use begin and end. It's kind of verbose and it's kind of ugly looking, but that's the way it is, so you'll have to get used to that. You'll use line termination still. It is a semicolon, just like other languages you're familiar with. There are, however, some differences when it comes to assignment, because you're not dealing with a microprocessor with pieces of memory, but instead dealing with what signals get put where and attached to what. There are a couple different kinds. First of all, you have to realize there are no variables, but there are things similar to variables called registers, which will have a persistent value based on what you give them. You assign them 1 bit at a time. You can make a bus, which is a whole bunch of bits together. Say you want 1 byte, you would create an 8-bit wide bus of registers. Now, as far as assignment goes, it's also important to realize that there are actually 2 classes of assignments that you can do. The most basic is using the assign keyword, which you will do whenever you're trying to attach something physically. Like if you're going to connect this wire to this wire, you would assign this value to here. So you'll use that for if you have a value in a register which you want to write, so to speak, to an output pin. You're not actually writing it because that implies an action. What you're doing is you're physically connecting that pin to that value. Anytime this value changes, this gets updated because they're physically connected. At least for the intents of how you want to think of them in terms of operation. There is also blocking and non-blocking assignment, which occurs on a non-continuous basis. This is what you do whenever you're doing an action on either the rising or falling edge of a clock signal, which is how everything is going to be done. Everything is based on a clock. And a clock signal is just a simple square wave. There is a rising edge and a falling edge, and those are the only 2 times you can do anything. Now, whenever you are on a rising or falling edge and you're trying to set a value equal to something else, like I said, there's blocking and non-blocking. Blocking means that any code below that point will have that new value in that register whenever you go to reference it. So say on line 1 you say register A equals 1 and you use a blocking assignment. Now on the next line, if you say if register A equals 1, it's going to be true, even if register A previously had a value of 0 prior to line 1. This is what you're familiar with whenever you're software programming. But this is not the kind of assignment you're going to generally be using because it is more resource intensive and it's not necessary for most tasks. Instead, you'll be using non-blocking assignment, which is a very different animal from what you're probably used to. Non-blocking assignment means, say you have register A, B, and C, and they all have a value of 0. On line 1 you say register A equals 1, so you assigned it the value of 1. That value is not yet valid. If you go to reference it on the next line by saying if register A equals 1, that's going to be false. It's going to return 0. This is important because most of the time you don't need the value until your next clock cycle. And by doing simple non-blocking assignments, you're saving a lot of resources. But it is important to think of it in that way. You have to realize that it's not going to be valid until the next clock cycle. Okay, so those are some of the basics in terms of values and how to assign them and what the different kinds of assignment do. Now, whenever you're dealing with assign, that keyword, that's always outside of sequential logic. When it comes to your design, you're going to have some familiar concepts. You have a top-level design, which is similar to the starting object in another programming language, which would be submain. In many languages, it would be perhaps a Windows form if you're used to Visual Basic, or it can be an actual module if you're used to, say, console.NET development. Now, this top-level design is the master control work, you would say. In this top-level design, you're going to be connecting all the various modules you have created, which are other pieces of hardware that you are instancing, so to speak. What that means is you have another piece of code which describes a piece of hardware with inputs and outputs, and you are connecting that, you're creating that and connecting it to inputs and outputs, registers, wires, whatever you have in your top-level design. Now, by combining these different pieces that you can create a very interesting state machine. You can even create an FPGA that has a microprocessor on it, a soft core. But we won't be doing any of that complex stuff today. We will be doing some basic work with LEDs and switches to start with, and this will demonstrate some of the language concepts. Without any further delay, let's get started.